Welcome folks. In this video we are going to look at science paper 1 for the year 2021, and this paper was written by the internal candidates. Now our focus will be on section B of the same paper. We'll have question 1. The following graph shows distance / time graph of a bus moving from town A to town B. So we have been given a distance time graph, and this distance time graph must be treated differently from the velocity time graph, because under velocity time graph you are given the velocity or speed under the y-axis, but for the x-axis is always time. Now how do we handle a distance time graph? So first we need to look at the initial or the starting of our journey. So point A is our initial point. This is where the journey began. Then whenever we have 2 or 3 or 1 point that is parallel to the y-axis indicates the stop. So our first stop is on this point here. So it's like a journey. You start a journey, then along your journey you stop for maybe to get something. So that stop under the graphing is denoted by a line parallel to the x-axis. Then the second stop is this one, and according to the information, B is the final point where the journey was ending. Now apart from that, we can now go to question A. What is the total distance between town A and town B? So the total distance is measured from this point, because this was the highest point reached by this line. So we are going to move right to the x-axis, then to the left side, so that we see at which number are we going to get on this point. So this is the number that we want. Now if you look at the scale under the x-axis, it's 2 centimeters represents 20 units. So we'll say 50. This small one means 2, so 52, 54, 56, 58. So the total distance is 58 kilometers. We move on to question B. The bus stopped at a station between town A and town B. For how long did the bus stop at this station? So the only station that we have between these two towns is this stop. Then the other stop was for the final. So what do you do to find the distance, I mean the time? So we want the time from here up to here. So what do you do? We need to first look at the number. So if you look at 2.1, this is 2.2. So we need to find a difference between 3 and 2.2, which is 3 minus 2.2. It's giving me 0.8 hours. So this is how long it took. Then go for question C. Calculate the speed of the bus between town A and the first station. So say speed is equal to distance divided by time. Then let's focus on the first journey. So this is our first journey here. So if this is our first journey, what is our distance covered? So the distance, we need to move from this point. Always the distance is gotten from the y-axis, so our distance is 30 kilometers. Then what is our time? If we move, time is 2.2. Then we are going to do the math here. So I'm getting about 13.6 kilometers per hour. Then question D. Calculate the average speed for the whole journey. So say average speed is equal to total distance divided by time taken. So total distance is 58 over, let's go back to our graph. Now in case of where if you get problems when taking the time for this one, the journey ended here. This is where the journey ended. It stopped from here. So we need to get the time from this point, because at this point the bus has stopped moving. So we are getting a 4. So we divide by 4. 58 divided by 4, I'm getting 14.5 kilometers per hour. Now move on to question E. Mention one consequence of overspeeding. So we can say can cause accidents. We move on to question 2. Under question 2a, we have state Newton's second law of motion. So the Newton's second law of motion is just the information that tells us the relationship between force, mass, and the acceleration of a certain object. So say a net force that acts on a body. We'll say that acts on a body, accelerates 80 in the direction of the force. Okay, then if you want, we can add some information, or the simplest definition that we can just give is that the acceleration is directly proportional to the net force and inversely proportional to the mass being accelerated. So say the acceleration is directly proportional to the net force and inversely proportional to the mass being accelerated. Okay, for example, the second law of motion can be summarized by this formula, where we have the net force here is equal to mass multiplied by the acceleration. So the first one, we are told that the relationship between mass and force, let's first begin with the acceleration and force, is that these two are directly proportional. Then the mass and acceleration, they are inversely proportional, which means that if the mass of an object increases, the acceleration decreases. Then the reverse is also true for mass. Now question B, the following diagram shows a 4 kilograms box resting on a frictionless surface with a force acting on it as shown. Now from the given information and our diagram, we are not going to put the friction into consideration because this question is same as we ignore the friction. So if friction is ignored, we are going to just focus on the forces that we are given. Now look at we have the force pointing on the right side, then we have also two forces that are pointing on the left side. So what this means that the 6 newtons and 12 16 newtons and 12 newtons pointing on the left side, these combine to make one force. Then only on the right hand side we only have 10. So how can we find the net force? So say net force is equal to, we'll say 16 newtons plus 12 newtons. So the reason why these are added because they are pointing on the same direction. Then we are going to subtract the 10 since this one is pointing on the right side, so minus 10 newtons. So 16 plus 12 is 28. Then 28 minus 10 will give us 18. So this is our net force. Now, after we are done finding the net force, we can now go to the question. So the question is calculate the uniform acceleration caused by the forces. So we'll say now acceleration is equal to net force divided by mass. So what's our net force? Where there is net force, we need to put this number 18 divided by what is our mass. Mass is given 4 kilograms, and make sure that mass is in kg. So 18 divided by 4, I'm getting 4.5. So newtons per kg, or we can just say meters per second squared. This is our final answer. We now move on to question 3. The question reads, the following diagram shows how energy flows into and out of a coal-fired power station. So we have the energy input. So this part is our input energy. Then these are output energy. Now, if you look at the first one, we have boiler, turbine, generator with 70 joules wasted in friction. Then we have wasted energy here. We don't have the number, we can just put X. Then 30 joules wasted in heating. Then 300 joules electricity produced. Now question A, how much useful electric energy is produced by the power station? So how much useful electrical energy is produced by the power station? So how do we calculate this question here? So from the question, the useful electrical energy produced is just 300 joules. So it is just 300 joules, where we've just gotten this number here. So this is a 300 here. So this was the amount of energy produced as electrical energy. Then we move on to question B. Calculate how much energy is wasted from the cooling tower. So from the cooling tower is this tower here, where I'll put X. So remember, we are saying the output must be equal to input if we consider this one to be efficient. So let's just put that point. Then under the output, the first one, we have 70 joules plus what else do we have? X plus 30 plus 300. This must add up to 1000. So say plus X plus 30 plus 300 must add up to the total. The input was 1000. So 70 plus 30 is 100 plus 300 is 400. So here we have 400 plus X is equal to. So if you do the math, you shift this number to the right side, we get X is equal to 1000. This becomes negative 400, giving us X is equal to 600 joules. So this was the amount of energy that was wasted at this point. So we have 600 as our final answer. Then the C, calculate the efficiency of the power station in producing electricity. So say efficiency is equal to, since we are dealing with energy, we'll say energy output over the energy input, then multiply by 100%. Now for this one, the energy output, we are just going to focus the energy that was just in producing electricity. We are not going to consider the other numbers, no. So our number on top, we just put a 300 joules divided by the input is always the one that was put in, so multiplied by 100%. So if you do math here, you get 0.3 times 100%, giving us 30% as our final answer. So this was the efficiency. So it means that from the 100% of energy that was put in, only 30% was useful. Then the other 70% is considered to be waste product. Okay, so we have question for a defined convection. So say the transfer of heat in liquids and gases. So this is coming from where if the molecules, let's say the molecule or molecules of a liquid such as water or air, if those are heated, then the density of a heated air is less than the density of a cold air. So that's the concept that we are trying to use here. Now we have question B. The following diagram shows an incomplete diagram of convection currents during occurring in nature at night. So we need to look at what happens at night. So for us to understand what happens at night, first let's see if we can analyze this one in terms of what happens during the day. So what happens during the day is that due to the presence of the sun, the land becomes warmer. Then the sea becomes cooler. So if this is the case, then the air on land becomes more denser than the air on the sea. So that is during the day. So during the day, then we know that the air that is less denser will go on top, while the air that is more denser goes on the bottom. So that is what we look at in terms of the convection current. It also occurs to the water molecules. Now during the night, the opposite happens. So during the night, since we said the land absorbs more heat during the day and faster than water, then it will also emit heat faster than water. So during the night, the land becomes colder. Then the sea becomes warmer. So if this is the point, then we are going to see that since the sea becomes warmer, then the air on the sea becomes less denser, then the air on land becomes more denser. So because if we look at the movement of these air molecules, they will move in this direction. So my point is, the air particles or molecules here on the surface of water will be heated up. So after they are heated up, then these air molecules will be forced to go on top. So whatever that has a lower density goes on top. Then whenever it goes on top, it is going to be cooler. At some point, this air will become more denser because they have moved to land where we have a cool condition. So here we have air that are very cool. So because they are very cool and they consist of the high density compared to the one on the sea, this now will move down. So this is what we call the convection current. So whenever we look at the convection current, we are looking at the movement of warm water, remember, will rise, while the cold water or air will go to the bottom. So that is the concept that we are looking at here. Now from here we can see that the air is coming from the land going to the sea. Then the breeze that we are dealing with is land breeze. So that's the concept here. Then if for question, on the diagram, draw convection currents for this breeze. We've done this. So this is our breeze. Then the reverse of this one will give you the sea breeze, and sea breeze occurs during the day. Okay, we move on to question 5. Under question 5, we are dealing with spectrum. List the components of the electromagnetic spectrum in order of increasing frequency. So list to the highest. So we are looking at in terms of frequency, increasing frequency. So you need to find ways or a mnemonic that we can use to remember the nature and also the sequence, the order of this electromagnetic spectrum. For example, we can use the common one, which is, we say Ross mass is very unusual. Say X mass gift. So what do we mean by this? So from the Ross we get radio wave, then M we have microwave, I we have infrared, then V visible light, U ultraviolet, then we have X-rays. From there, the last one we have is G, where we deal with gamma rays. Then we move on to question B. Mention one similarity among the components of the spectrum. So we are indirectly looking at properties or characteristics that can be found, and those characteristics must make sure that they are obeyed by any of these waves. So the first one, we can say they are all transverse waves in nature. The second one, we can say they travel at the same speed. And the speed is 3 times 10 raised to the power 8 meters per second. Then we can also look at they all carry energy and they can all travel in a vacuum. Then see, mention one difference among the components of the spectrum. So the difference is in terms of the wavelength and frequency. So the wavelength and frequency. Then give one Helmholtz effect of the spectrum. So here we can just look at in terms of skin color. So we can just say they can cause skin cancer. Move on to question B6. The following diagram shows an ultrasound sending a sound wave into the human body. So we have the flesh here, then in between here we have the bone structure with the distance Z. Then the total time for the ultrasound to travel in the bone from X to Y and back to X is 9.0 times 10 raised to the power negative 6 seconds. Then question A, what does the term ultrasound mean? So if you look at the human audible range, is given from 20 up to 20,000 Hz. Then Sound with frequency less than 20 is called infrasound. Then the one above 20,000 is called ultrasound. So whenever you look at ultrasound, we are looking at the sound with a frequency greater than the human range. So say a sound with a frequency greater than human audible range. Right, so move on to question B. If the speed of the ultrasound in bone is 4,100 meters per second, calculate the Z, the thickness of the bone. So we are looking at the echo. So we are going to use the formula. Speed is equal to 2 times D over time taken over 1. We cross multiply. So 2D is equal to S times time. Now what do we mean by 2D? The distance of going from X to Y and the distance of coming back from Y back to X. So we have the going and coming distance. That's why we have 2 from the echo. Then we'll say 2D. Okay, so since we are solving for one distance, we need to divide by 2. So over 2 over 2. So whenever you want one distance given the echo information, this is what to use. So the speed is this number, 4,100 times the time given is this number, which is 9.0 times 10 to the power negative 6. Then you divide by 2. So we can just do the math here. 4,100 times 9 raised to the power negative 6, then divided by 2. So I'm getting 0.01845 meters. If you want, we can write it as 1, 2. So this is same as 1.845 times 10 to the power negative 2 meters. Then C, mention another use of ultrasound other than medical use. So say to measure depth of seabed. Move on to question 7. 7A, define reflection of light. So say this is the bouncing of light after striking a surface. Then we'll move on to question B. So question B, we are looking at the image formed by reflection. So the following diagram shows a dog and a cat standing in front of a plane mirror. Using the diagram, show by construction how the dog sees it. So the observer, this is our observer, is our dog. So the cat will be used as our object. Then the image is formed behind the plane mirror. So under reflection, the image is formed behind the plane mirror. So what are we supposed to do? We are going to write the incident and the normal plus the reflected ray. So the first step that you're supposed to know here is that you need to draw a line from the object. Then please make sure you use a rule. So you draw a line from here, then it needs to go to the observer. Now how do you write the arrows? So the arrows must point into the eyes of the observer. Then from there we are going to draw the normal ray as usual in dotted lines. Then since the image is found on the other side here, from this point you need to draw a dotted line. The reason why it is dotted, because we are just imagining the image is there. In actual sense the image is not there, it's virtual. Now what you need to know is the distance from the object to the plane mirror must be equal to the distance from the plane mirror to the image. So these two distances must equal to each other. In case you are given some calculations, but I don't think we can be given calculations here. So question C, give two characteristics of the images formed by the plane mirror. So the first one is it is virtual. Then the second one is the distance. So we say distance of an image is equal to the distance of the object. I didn't see that I have enough space here. So it's equal to the distance of the object. Then we can also look at the size. So the size of an object must also be equal to the size of an image. So those are some of the characteristics that we can give here. Move on to question 8. So the following diagram shows a graph of voltage against currents on a conductor. Then we have voltage in the y-axis and current in the x-axis. So the question is, what is the maximum current through the conductor? So the minimum is at this point. Then the maximum is gotten from this point where the line is ending. So since the question is we want maximum current and current is in the x-axis, we move down here. So you can see that the number that we are getting is 3. So the maximum current is 3 amps. So if 3 amps is the maximum current, then our maximum voltage is 6 amps. Then calculate the resistance of the conductor when the current is 1.0. So resistance is equal to voltage divided by current. Current is given is 1. So our task is we need to find voltage when current was 1.0. So current, when current is 1.0 is here. So we move from this until it touches our curve. Then after that we need to turn 90 degrees to the left. So if this is 0, then here should be 1. So it's 1, which is 1 into 1 is 1 ohm. Right, we move on to question C. Calculate the power in the conductor when the voltage was at 6 volts. When the voltage was at 6, then current was 3 amps. So say power is equal to voltage multiplied by current. So voltage is 6 times 3, giving us 18 watts. Okay, we move on to the last question. So last question, we are dealing with radioactivity, which is we are looking at the fission and fusion, but our focus is on fission. So fission is the splitting So an atom splits after bombarding a moving neutron. Then the fusion is joining. So please remember these two terms. So define nuclear fission. So say this is the splitting of heavy atoms to form lighter ones and energy. So during nuclear fission and fusion, energy is produced. Then we have been given some information. Uranium-235, when bombarded with a slow-moving neutron, disintegrates into barium and krypton plus 2 neutrons. What term is used to describe the products of nuclear fission? So the products are barium and krypton. So these, we can just call these as fragments. Or if one, we can use daughter atoms. Then Roman number 2, given that the products of this reaction are barium and krypton plus 2 neutrons, write the equation for this reaction. So we go back to our question. So the parent atom is uranium with the mass number of 235 and the atomic of 92. So it's what we are going to use. So uranium 235, 92. Now we are told it bombarded, so we need to add 1 neutron here. Then we are given the first product is barium with 144. We have 56 here, plus krypton 90, 36 Kr plus C, 2 neutrons. So you need to follow the information. So this is 1 neutron, so 2 neutrons you put 2 here. Now what you need to make sure that the mass numbers on the left side must be equal to the mass numbers on the right side. So on the left side we have 235 plus 1 is 236. Here we have 144 plus 90 plus 2 times 1, which is plus 2. So let's check if our answer is correct. So 144 plus 90 plus 2, so I'm getting 236. So my answer is okay. Even if the atomic number must also be equal. So 92 plus 0 is 92. 56 plus 36 plus 2 times 0 plus 0, which is still 92. So this is our equation. Then question C, name one harmful effect of fusion reaction. So can cause mutation if you are exposed. So can cause mutation, can cause cancer. Then give one advantage of nuclear reactors as a source of energy. So the most advantage for nuclear is that it produces a lot of energy. There are so many, so it depends on the one that you'll be able to remember. So that's it for this video. Thanks for watching.